poster we're looking at is about the Passage Organizer Extractor application. The abbreviation for that is POE. We designed this application to help test developers find excerpts from long texts that they could use on our English test to write items about.
Okay.
That's a long and costly process to look for passages in hardcover books. Sometimes we write these from scratch. So the goal here is to put in texts that we can use that are digital, scan them with a computer. We analyze potential passages for things like reading level and for cohesion. So that lets us know that a topic is intertwined throughout the whole passage, so it doesn't abruptly change topics in the middle.
That's Brad Bolender talking about Passage Organizer and Extractor, or POE. We'll join him again at the end of the show. I'm Adam Burke. In our last podcast episode of ACT Next Navigator, we talked about automated essay scoring. Today we're discussing what goes into creating assessments, specifically the automation of assessment creation. Writing tests by hand is an intense process. Test items take many hours to create, check, field test, and verify for fairness and accuracy. My guests are Rick Meisner, Ian MacMillan, and Brad Bolender. Rick Meisner is an expert on AIG, Automated Item Generation. He's been with ACT for 30 years and programmed ACT's first automated item generation in the programming language BASIC.
I'm Rick Meisner, and I started at ACT in 1988 as a math test specialist, so I've been here about 31 years. The whole time in test development, I've been in various positions, from math test specialist to more software development-oriented positions. I'm currently with the Automated Content Generation Group in ACT Next.
Walk us through how you create a test. What goes into all that?
A really straightforward example from math might be if we want to test whether the student understands the concept of how to calculate an area of a rectangle. We could make this a word problem. Maybe something like a plot of land is 25 feet wide, 200 feet long. What's the area in square feet? The key would be 5,000 square feet, 25 times 200. And the distractors, for those we would try to reflect misconceptions, like maybe the student would confuse perimeter with area, so the perimeter might be one of the answer choices. They might add the two numbers instead of multiplying the two numbers. That could be another one of the distractors. Leave off a zero on the actual answer and answer 500 instead of 5,000. That could be one of the distractors. After the item is pre-tested, we like to take a look at how those distractors performed. If one doesn't really draw many responses, we might, in the future, replace it with something else that does work better.
That's a little more closer, or...
Yeah, more attractive to the students.
Okay, so distractors, attractors, kind of, you're playing a game between those two things.
Yeah.
And the answer would never be like 3 or elephant or
right
or something like that.
Yeah, that wouldn't have much value because nobody would pick it, and it wouldn't add any information that would help us discriminate between high and low ability.
Okay. AIG is auto item generation, and we want to explain this to people who maybe have never thought about it or thought about when you make a test that there is a way that a machine could do it instead of writing out questions and answers by hand. So what do we mean by AIG, or automatic item generation?
So again, we could illustrate that with our math item example. With the example item and with most math items, the numbers in the stem are pretty arbitrarily chosen. You're just picking a number that will help illustrate whether the student has the corresponding knowledge or skills. But it doesn't have to be 25 feet wide by 200. It could be 15 by 300. You have a wide range of choices for the numbers. So this is something a computer can handle with random number generation to generate all kinds of variations on the item that would still test pretty much the same skill. So if we turn this item into a sort of more abstract item model where we say a plot of land is fill in the blank feet wide and fill in the blank feet long. The computer can randomly fill in those blanks, and you can have 100 items of the same type, all a little different, all testing the same skill. There are a lot of advantages in having that many different items to reuse. There are parts of the stem that stay the same, parts of the stem that are filled in. They're more variable. Depending on what they get filled in with, you would recalculate the key so that it's still correct with those new numbers and the distractors so that they still reflect the same misconceptions as before.
To me, that makes sense. Math seems easy. Mm-hmm. And you've been doing AIG with math for a long time.
Since about 1992. That's when I was still a math test specialist, so I was seeing a lot of these items and thinking, if you have one item, you could just as easily have 100 very similar items. We had just received these new machines on our desks called personal computers, which had programming languages built in, a very early version of BASIC. Playing around with that, it was pretty easy to generate items from models. So we began doing that, mostly to fill in weaknesses in the item pool. There are always certain types of items that are a little underrepresented. Automated item generation really helped to kind of fill in those weak areas, which makes form assembly go a little more smoothly because you're not short on anything.
What was that like when you said, or your team said, let's do this automatically? Was it kind of a game changer?
It was embraced right away by management. They really wanted us to pursue this because I think a typical item costs about $1,000 or more to develop. When you add in item writer costs, all of the staff time involved in editing, fine-tuning, all of the reviews, soundness reviews, fairness reviews, external reviews. So when you can generate an item that you know is going to be sound because it's based on an already tested item, and when you can do it that quickly and easily, there's quite a savings in time and cost.
But you're not all the way there with math. There's still some challenges.
Right. A lot of math items involve graphics. If you change the numbers in the stem, often the figure or the graph will have to change. If you're plotting a line in the XY coordinate plane, the slope changes or the points change. That means the graphic has to change also. And that's a little more challenging to do. That's still in an early stage, but we're looking at possible tools that we can incorporate for making that easier.
And is that the AIGL that we'll talk about later?
That would apply to some of it.
Okay.
Anything involving a data representation like a bar chart.
Oh, okay.
Or, we're working, the AIGL project is already able to incorporate those kinds of variations in bar graphs and line graphs. So we hope to bring that over to the ACT math test as well.
So math, again, that seems pretty straightforward to me, that
Right.
you could just flip some variables in and out and come up with an unlimited number of items, really.
Right. Yeah, it's all based on numbers and algorithms, and computers are really good with those.
And then English is another one of our tests in the ACT.
Right.
And that gets a little more tricky.
It does. It took us a long time to even really think of a way to do it, because now you're dealing with a lot more entities. What's relevant in an English item is punctuation or subject-verb agreement, words, phrases, linguistic rules instead of mathematical rules. Additionally, these are based on essays. The items are all embedded in an essay. There was the challenge of coming up with a way to sort of generalize item generation across essays, and to do it with words, phrases, types of words, types of phrases, which, as far as we know, hadn't been done before at all.
So that's an ongoing project, sounds like.
Yeah, we've made quite a bit of progress. We did a prototype in 2016, I think, late 2016, with 6 item models.
Are there any additional possibilities for ways to apply AIG in the future that you can see? What's kind of coming down the pike?
It can definitely be used for more than what we're using it for. Our particular need is generating content for assessments, but you could picture AIG use in the classroom. I think it's already being used in the classroom to some extent for things like generating worksheets. If you want to test a particular skill or set of skills, ask the AIG software to generate items in those areas. You could actually even generate parallel but different worksheets where the items are a bit different from each other, no chance for copying.
So within a class, you could have 4 or 5 tests being passed around.
Sure, and they're all testing the same skill.
Yeah.
AIG makes that fairly straightforward. So for practice, for repeat assessment, the distractors in multiple choice items capture misconceptions, so there's some diagnostic value there. So you could picture generating the item, looking at patterns and misconceptions, maybe then routing to remedial learning resources to address those misconceptions, then maybe retesting with more generated items in the same skill. It could become part of a whole integrated system of that kind.
We'll talk more about classroom applications for AIG and passage extraction with Brad Bolender and his POE project later in the show. Now let's visit with Ian MacMillan at his AIGL poster. AIGL is Automated Item Generation for Testing Graphic Literacy. So I'm in the ACT Next annual EdTech event poster session. I'm going to talk to Ian MacMillan about AIGL. Let's find out what that is. Okay, we're standing in front of the AIGL poster that Ian MacMillan made, and he's going to talk a little bit about graphic literacy and automatically generating graphs and item questions. So Ian, tell me what you do and how do you do it?
Yeah, so I work in the assessment strategy group within ACT Next, and what I've built here is a program that automatically generates items and graphics simultaneously. The graphic literacy test is a test of your ability to work with graphs, like bar graph, line graph, table, chart, pie chart, pulling out information, drawing inferences, identifying trends, things like that, working with data. What this proof of concept did was I really just sort of went for the simplest item type that we had, which is locating information.
And I'm looking at a very simple bar chart. It says cars sold in 2 countries across 4 quarters, and it's Lithuania and Macedonia. You found some data that created this graph.
I found the data in my own head. I made this up. I made up the data for this purpose.
Okay.
But any realistic data that you might find could be filtered into the program and work just as well.
Okay. And you said you used to do graphic literacy generation of items by hand, kind of like researching, finding data
Correct.
you had permission to use.
Yes.
And you would do kind of the same thing, create a graph, and then create some items and questions from that.
Yes, that's right. For a few years, I was writing graphic literacy items across the entire test, across all difficulty levels and all types of graphics.
4 work keys.
4 work keys, that's absolutely right.
And each one could have taken you, I think you said, an hour or less, depending.
Oh, yeah, there's always a lot of variation. Sometimes you get lucky.
Okay.
Sometimes you can make up data.
Okay.
Used to be a college professor. I'd make up graphs about student test scores and then just off the top of your head think about a regular distribution of scores and then create a graphic. And that's realistic because that's the same kind of data that a teacher might use. That's another way that we would create graphics, is just by taking our own expertise and using that to create a graphic. But usually we find graphics that are about subjects that the person writing the item is not necessarily an expert at the subject matter, but they may be very good at analyzing the data. They might not know where the bars came from in the bar graph or what they represent or mean, but they know how to ask questions about them once the graphic is sort of given.
Okay. The graph is called a stimulus.
Correct.
And that's kind of the first part of the question. So a test taker would look at this graph, and then they go down to the items, which are questions.
Correct.
And each question has the right answer, obviously.
Yes.
It's A, B, C, or D, multiple choice. And then there are 3 what they call distractors,
Yes.
which are the wrong answer.
Incorrect answers.
And I want to get that terminology so people know what we're talking about.
That's right. So we've got
automatic item
we've got the
generation.
graphic stimulus
Yeah.
and the items. What AIGL does is it creates the items and the graphics from the same data
Simultaneously, and it
Yes.
takes seconds.
in seconds.
And so this is phase 1, is this kind of proof of concept, very
Yes.
simple bar graph.
Yes.
And it generated 4 item questions.
This is now, in fact, a sample. I actually produced 192.
192 items and question sets?
For every 4 graphs, you get a bar graph and a line graph.
Oh, okay.
And there's 192 items
Okay.
divided into 4. That gets you somewhere 40, 50 or so graphics.
40 or 50 so bar or line graphs.
Right.
And 4 questions per.
Right. That these come in. Right. That these are sort of in groups. That we've got 2 groups of bars, red bars with blue bars.
Okay.
What these 4 questions are asking about are simply asking about the red bars.
Oh, okay.
The program, and you see these questions are numbered 1, 2, 3, 4. Those are literally the first questions to be output from the program. Instead of talking about cars being sold in 2 countries, right? That's the title of our graph. We might talk about boats being sold.
Okay.
And then that creates a whole new universe from which you can start asking mostly the same question.
It's all about being able to read a graph and answer questions accurately. How many cars, in this case, were sold?
Yes.
And this is one of the tests in work keys,
Yes.
graphic literacy, and the other one is
Reading
kind
for information, or excuse me, workplace documents.
of workplace documents, which
And
is kind of
apply-
reading
yes.
for information and extracting text.
and applied mathematics.
Okay, basic math questions.
Correct.
So that's phase 1, is this kind of simple bar graph and generating questions.
Yes.
What's in the future?
Yeah.
Phase 2 or the next phase?
So phase 2 is going to focus on the graphics themselves, and then phase 3 will work to integrate the graphics back in with additional kinds of items,
With items. Okay.
additional types of skills, harder test questions.
Okay.
Questions that are more difficult. The proof of concept really just asks you to be able to identify, say, a particular point in a graphic. Some of the more complicated items ask you to identify a trend or recognize a pattern.
Okay.
Some of our hardest level skills will ask you to actually go beyond the data and draw an inference or make a decision. Different item types are going to require different types of graphics to go along with them. Again, phase 2, working on the graphics side. Phase 3, integrating graphics with items again.
And on this future side, we have a difficult bar graph, a high moderate pie chart, high moderate line graph, different kinds of graphs you can generate from data, and you do it all in Python.
Correct.
And how does it work in Python? You kind of feed it data and then it spits out a chart?
Yes, it reads an Excel file and uses the data in the file to create the graphs and the item text.
Wow. And the distractors, so not
And the
just the right
distractors
answers.
as well. Correct.
So you don't have to go in.
Everything that you see in the items and in the graphics, all of the sort of particular details that make it what it is, are based in the data file.
And you say this has not been implemented into work keys yet.
No.
But how long do you think that'll take?
I don't know. We haven't really talked about that yet because right now we're more interested in exploring the capabilities that we can build and seeing what's possible. I have been in some discussion with people that are currently writing graphic literacy items manually, and they're actually part of the project team, and I'll talk with them as we go. But for now, I'm sort of working by myself because I've written items for the test for several years. I know exactly how it's supposed to look. So in a way, I'm my own consultant.
Yeah, sure. Subject matter expert.
Yes, I'm both the subject matter expert and the programmer in this case.
Okay. That's great. Thank you, Ian. And now let's head over to the poster presentation from Brad Bolender. Brad has created a program to identify passages used for reading and science test items from publicly available texts and books. Users can select variables to get the exact length and grade level they want to assess. So technically, POE is not automated item generation, but it's a device that helps find text passages that leads to the creation of test items. So why don't you introduce yourself and then tell me about POE and what it does.
I'm Brad Bolender. I'm talking about the Passage Organizer Extractor application, otherwise known as POE. I've been at ACT for about 12 years. I started on our English language arts development team and moved over to some more computer approach kind of stuff. Now moved into ACT Next. POE is an application that can take a whole book, slice it up into pieces, and pull out sections of that book that meet certain criteria. That could be criteria for a test developer or a learner. We designed this application to help test developers find excerpts from long texts that they could use on our English test to write items about.
Okay.
That's a long and costly process to look for passages in hardcover books. Sometimes we write these from scratch. So the goal here is to put in texts that we can use that are digital, scan them with a computer. We analyze potential passages for things like reading level and for cohesion. So that lets us know that a topic is intertwined throughout the whole passage, so it doesn't abruptly change topics in the middle.
Okay.
And we can compare the potential passages that are output from this application to what is a typical English essay. And then those that are the most similar to the typical English essay are sorted to the top so that test developers can look for ones that are close to final state that they could use on a test, with a little bit of work, of course.
Okay.
A few teachers actually stopped by to look at this poster, and they were interested in the possibility of inputting book-length texts that students are interested in and slicing them up into passages they could use for lessons. And so that's something that we haven't even really considered yet. We were designing this application to help test developers, but that would be great if we could extend it.
Use it as a resource, kind of.
Yeah.
And I see you have kind of some sliders here, so you can put a word count range, a grade level range, sentence count, and paragraph count. And you can slide these, it looks like, a lot of different ways, and then in a book, find how many little 300, 400 word passages might be good for tests.
That's exactly right.
Okay, and no item generation though, is that right?
We're working on that, Adam.
Okay, that's next.
Yes, we are currently working on that right as we speak, so that we can start to analyze these passages to know how many items we can generate for these individual passages right now. That way we can start to pick the ones that have the most value to us that we can automatically generate the items right away.
And it gives you a ranked list already, so you know these are probably the good ones, and then you might not even get to the bottom of the list.
We're implementing that. It's we've done that on the back end on the research bench.
Okay.
But in the development of the application, we're working on incorporating that part of it.
Okay. And this says version 2.
Correct.
What will the next version have that this doesn't have?
Well, the next version is going to analyze the passages to find how many items we can generate, just like we just talked about, because that's what we're working on now. So
Okay.
that's the goal.
What else can you tell me about this?
Right now, what we're working on is for it to find opportunities for items. Rick Meisner has developed the Aegis application that generates the actual items.
Of English subject.
Correct.
Okay.
Yep. Developing stimulus passages for the English language tests requires a considerable investment of resources. In order to assist with this process, the Passage Organizer Extractor, or POE application prototype was developed. Test developers can upload a full book-length text, and POE will segment the text into potential excerpts that meet criteria such as length, reading level, and cohesion.
Okay. And you developed this app?
That's correct.
What is this Shiny in RStudio? Who's that?
The app is developed in it was developed in the R programming language with the Shiny application framework.
Okay.
And then we have posted it on an Amazon web instance where now developers can access it through the web browser right at their desks.
Really? Is this being used today for tests?
We have found 5 passages with this application that were developed into units for the ACT test and are in field testing right now.
Oh, they're field testing stuff that
we expect they'll come back just fine, and they'll make it all the way onto the test.
Yeah. And what's your background? Were you a SME before this, or did you do item generation?
I was a language arts test developer for about 3 years before I came over to assessment strategy and learned to start applying some of this computational approaches.
When did you learn how to program in R?
I learned how to program in R about 5 years ago. It attracted me because it's the research programming language, and I was interested in what we could do with ACT data sets. And so I dove in and learned everything I could about it, did tutorials, read blogs from rockstar R programmers and things like that.
Were you a coder before that?
Not really.
Basic. Nothing.
Sort of.
Nothing this in depth.
I had tinkered, but I had never got anywhere near building a whole application.
Yes. Wow. How long did it take you to build POE?
I've been working on it off and on for a couple of years.
Thanks, Brad. Thanks for talking to me.
Thank you.
That's our show. Thank you, Brad, Ian, and Rick, and thank you for listening to ACT Next Navigator podcast. If you missed the 2019 poster show, we'll do another one next year, probably in October, at the annual ACT Next Education Technology event. You can follow ACT Next on Twitter and LinkedIn. We also have a medium.com Navigator page.